Hello students, today we're going to do some parallel lines practice with the parallel lines theorems as well as their converses. The first thing that I want to do is walk us through the parallel lines reference sheet. So this was an assignment that you had last week, was to create a reference sheet with all of the theorems on it that would help you get through your parallel lines practice. Some of you expressed that you were having some trouble with that, so we're just going to go through and fill these out one by one. So the first one on the list was vertical angles. Vertical angles is a very useful theorem that we can use. Vertical angles happen when I have two straight lines that cross each other like this. And basically what happens is the angles that are directly across from each other are called vertical angles. So I could say that A is equal to B and C is equal to D. And the reason for both of those would be because of vertical angles. The next item on the list is a linear pair. Linear, keyword there is line. So if I have a straight line or a straight angle which measures 180 degrees, if I split that into two angles, regardless of how I split it, now I have two angles A and B, and I can now say that angle A plus angle B is equal to 180, and the reason that I can say they add up to 180 is because they are a linear pair. Next item is the transitive property, and the way the transitive property works is if A equals B and B equals C, then A equals B equals C, we make a little train of our equals, and then we just take the front and the back. If A is equal to B is equal to C, then A equals B equals C, so A is equal to C. The way we would see that in a proof is we would have a statement like step 1, X is equal to Y, and that would be given. Step 2, Y is equal to Z, that would also be given. And then step 3, I can now say X is equal to Z because of the transitive property. Okay, corresponding angles. This is a really important one because between linear pair, vertical angles, and corresponding angles, we can build all of the rest of the theorems. So if I have two lines that are parallel, we'll call them line L and M, and they're cut by a transversal line that we will call N. Corresponding angles are angles that are in the same spot but on different lines. So right here I would say this is A and this is B, or this is C and this is D. So the way this would work in a proof is I would first have to establish that L and M are parallel. So this only works if the lines are parallel. So I could say L is parallel to M, and that is given. And then I could say A is equal to B, so that would be this one and this one, because of corresponding angles. I could also do the same thing with C and D. C is equal to D. Again, they're in the same spot, but on different lines. Corresponding angles. The corresponding angles converse. Remember, anytime we see converse, that means it's going in the reverse direction. So the corresponding angles theorem said if the lines are parallel, then the angles must be congruent. This is going backwards. If the angles are congruent, then the lines must be parallel. So I'm going to go ahead and start same exact picture. This is L, this is M, this is N, and I'm going to have A and B here. But in this case, I'm going to start off with my given being that A is equal to B. So if A is equal to B, and that's given, then step 2, L must be parallel to M because of the corresponding angles converse. Okay, alternate interior angles. Same picture. L, M, N, and this time we're going to start with them being parallel. So remember, alternate interior. Interior means it's on the inside of the parallel lines. Alternate means on different sides of the transversal. So two angles that are on the inside of the parallel lines but on opposite sides of the transversal would be A and B. So if the lines are parallel, alternate interior angles are congruent. So I would say L is parallel to M. We're starting off with that, so that's given. Step 2 would be A is equal to B because of alternate interior angles. The alternate interior angles converse we would start off with the angles being congruent. So we would say step 1, angle A and B are congruent. That's our given. And then since the alternate interior angles are congruent, that lets us know that the lines are parallel because of the corresponding angles converse. Okay, alternate exterior angles. Same picture. Starting off with them being parallel. Same thing as alternate interior, but this time they're exterior, so they're on the outside of the parallel line. So this would be A here and B here. But I would say, starting off, if L is parallel to M, that's given, then A must be equal to B because of alternate interior angles. Okay, alternate interior angles converse. So we would say, if I know that A is equal to B, so starting off with A equals B, and that's given, then L must be parallel to M because of the alternate interior angles converse. Okay, consecutive interior angles. So, same picture, L, M, N, starting off with these being parallel. Consecutive interior means that they're on the inside, but they are on the same side of the transversal. So that would look like that. So I would start off saying, step 1, L is parallel to M, and that is given. Step 2, I can say, A does not equal B on the consecutive ones, but they are supplementary, so that means A plus B is equal to 180 degrees because of the consecutive interior angles. So if the lines are parallel, then the consecutive interior angles are supplementary, which means they add up to 180 degrees. Consecutive interior angles converse would be, here's A, here's B, L, M, N. I would say step 1, A plus B equals 180, and this is the thing that I start off knowing. If I know that A plus B is 180, then I know that L must be parallel to M because of the consecutive interior angles converse. Consecutive exterior angles. So consecutive exterior, same thing, except now they're on the outside, and just like consecutive interior angles, these ones are supplementary. So for the consecutive exterior angles theorem, these would be parallel. So I'd say step 1, L is parallel to M, given. Step 2, A plus B is equal to 180 because of the consecutive exterior angles converse. Oh, just kidding. Okay, now we're on the consecutive exterior angles converse. So just to clarify, that was a mistake right here. This is consecutive exterior angles, not the consecutive exterior angles converse. Sorry. The consecutive exterior angles converse. So again, just like the other ones, we don't know that the lines are parallel here. But if we know that A plus B is 180, so I would say step 1, A plus B equals 180. That's given. Then I would say L is parallel to M because of the consecutive exterior angles converse. Okay, so that is all of the vocabulary that we need for this this lesson. So you should have these definitions written out, keep them on a sheet, keep them handy so you can reference them quickly. That should help you a lot on the coming assignment. Hello students, today we're going to be doing some extra proof practice, and so what I'm going to do here, I know this is a topic that a lot of people really struggle through. I'm just going to do the entire assignment right here, so this video is going to act as your answer key. So in this one right here, actually anytime we do one of these problems, I want you to go ahead and pause it, see if you can do it on your own, and then come back and watch through how I do it and see if it matches up. Now, also a lot of the times when we're doing proofs, there's more than one correct way to do it. So just because you don't do it the exact same way as I do, doesn't mean that you're incorrect. So looking at this one, first thing I see is N is parallel to M, and that's given. So I'm just going to mark that on my picture. These are parallel. And what I should be thinking is anytime I see that there are parallel lines, I'm allowed to use alternate interior, alternate exterior, consecutive interior, or consecutive exterior, along with corresponding angles. So the first thing that it says is A is equal to H. A is equal to H. So I want to look at those and say, why are those two congruent? Well, the lines are parallel. A is congruent to H. That is because they're on the outside and they're on opposite sides of the transversal. Those are alternate interior angles. Okay, C plus E is equal to 180. So I've got C and E. I put 2 there because they're not necessarily equal to each other. C plus E is equal to 180 because the lines are parallel, and those are consecutive interior angles. And now that I'm writing that, I'm seeing that I made a mistake just a second ago. Very first thing that I wrote, A is equal to H. Those are not interior angles, those are exterior angles. Sorry about that. Okay, A is equal to D. Now, we have a lot of students mess up on this one because they say, well, A is exterior, but D is interior. And the thing I want you to focus on is I actually don't even need both parallel lines to get to A and D. So if I'm not using both parallel lines, I shouldn't be using any of my parallel line words. A and D are actually congruent because of vertical angles. They're directly across from each other. And F plus H is equal to 180. So I've got F here and H here. And again, those don't use both parallel lines, so I shouldn't be using the parallel lines vocabulary. F and H add up to 180 because they are a linear pair. Okay, moving on to number 2. Okay, R is parallel to S and 1 is supplementary to 3. Now the reason I brought this one up is this is one that we used on a quiz, and I wanted to bring up how to go over that. So number 1, I'm going to just state my my givens. R is parallel to S, and that's given. Step 2, I can say measure of angle 1 plus measure of angle 3 is equal to 180, and that's because of the definition of supplementary. Okay, step 3, since R is parallel to S, I'm allowed to use my parallel lines vocabulary. So here's R, angle 1 and angle 2. I can say that those are congruent to each other because they're corresponding angles. So now I can say measure of angle 1 is equal to measure of angle 2 because of corresponding angles. Now, what I want to do here is take step 2, which says 1 plus 3 is 180, and then step 3 says 1 is the same thing as 2. So I am just going to take angle 2 and replace it in right there. So for step 4, I'm now going to say measure of angle 2 plus measure of angle 3 equals 180. The reason I'm allowed to swap out things that are equal to each other, we would say substitution. So now at this point, I've shown that 2 plus 3 is 180 degrees. So that means that angle 2 and angle 3 are supplementary. So since angle 2 and 3 are supplementary, I'm looking at this right here. Here's M, here's N. Angle 2 and angle 3 are consecutive interior angles. So if consecutive interior angles are supplementary, then the lines must be parallel. So step 5 would be line M is parallel to line N because of the consecutive interior angles converse. Okay, now this is a smaller proof. We're going to do a couple of these that are just 1 or 2 steps. So A is equal to H, prove that N is parallel to M. So step 1, I'm just going to say A is equal to H, that is given. I want to go here and mark that on my picture. A is equal to H. Well, looking at A and H, they're exterior angles and they're on the opposite sides of the transversal, so those would be alternate exterior angles. And if the alternate exterior angles are congruent, then the lines must be parallel. So now I can just say N is parallel to M because of the alternate exterior angles converse. And that's it. If A is 10 and G is 170, prove that N is parallel to M. So let's go ahead and fill that in. A is 10 and G is 170. So I'm looking at the relationship between A and G right now, and those would be consecutive exterior angles. So what I would say here is 1, A equals 10, G equals 170, that is given. Step 2, A plus G is equal to 180. We could call that algebra. Now what I've done is I've shown A plus G is 180, angle A and G are supplementary, and if consecutive exterior angles are supplementary, then the lines must be parallel. So now I can say N is parallel to M because of consecutive exterior angles, converse. Okay, number 5. Given that D is 45 and G is 135, prove N is parallel to M. So again, step 1, D equals 45, G equals 135. That is given. So let's fill that in. D is 45 and G is 135. Now this one's kind of weird because they are not corresponding angles. They're not any of my other angle pairs, and so the angles as they are right now don't do any good for me. So what I have to do is use those angles to find another angle that's going to help me. There are lots of different ways to do this. The way I would like to do this is I would just use vertical angles. So if G is 135, then I can just jump across here with vertical angles and say F is also 135. So I can say, step 2, F is 135 because of vertical angles. And now I can go ahead and say, for step 3, looking at these two angles right here, I can say D plus F is equal to 180. That's algebra. And now that I know that those two angles are supplementary, I can now say N is parallel to M because of the consecutive interior angles, converse. Okay, number 6, we're starting to get into larger tic-tac-toe type problems. So step 1, given P is parallel to Q, N is parallel to M, and that is given. Let's mark that on our picture. P is parallel to Q, and N is parallel to M. We're trying to prove that A is equal to Y. So what I want to do here is start at A and work my way over to Y. So since P is parallel to Q, I'm allowed to jump from that ABCD angle cluster to the RTSU cluster. But also since N is parallel to M, I'm allowed to jump from the ABCD cluster into the EFGH cluster. What I'm not allowed to do is go from the ABCD into the WXYV. Should have started on V there. Anyways. Okay, so there are lots of correct ways to do this. The way I would do this is I would say angle A can jump over here to angle R using corresponding angles. So I'd say step 2, angle A is equal to R because of corresponding angles. And now once I'm at R, I can go from R to Y because those are alternate exterior angles. Step 3, R is equal to Y because of alternate exterior angles. And now, since A is equal to R and R is equal to Y, I'm allowed to say A is equal to R, which is equal to Y, so A is equal to Y, and that is called the transitive property. Okay, next one. Given that P is parallel to Q and B is equal to W. So let's go ahead and mark that. P and Q and B is equal to W. Prove that N is parallel to M. Okay, so step 1. P is parallel to Q. B is equal to W. That is given. So the next thing that I can do here is I can jump from a cluster in the P line over to the cluster in the Q line. So where that's going to be helpful here is either by taking an angle from this cluster and comparing it to an angle in this cluster, or I could also go the other direction, take something from here and bring it over to here. What I can't do right now is take something across here. I also can't go across these ones because I don't know that N is parallel to M yet. So again, let me erase some of this. It's getting kind of cluttered. I can't say something like B and F are equal right now because N and M, I don't know if they're parallel yet, so I can't make that jump. What I can do though is I can go from B to S using corresponding angles. So I can say B is equal to S because of corresponding angles. And now, if B and S are equal and B and W are equal, then S must be equal to W. So I can say that like this. S is equal to B is equal to W, so therefore S must be equal to W. Again, that's called the transitive property. And now that I've shown that S is equal to W, I can now say N is parallel to M because the corresponding angles are congruent. So, corresponding angles converse. Now, this is one that has a lot of correct solutions. So, just to show you how we could do a different solution, I'm going to go ahead and erase this and do something else. Okay, so again, keeping my givens, if I had chosen to start at W, I could have said W and G are congruent. Step 2, W is equal to G, and that would be because of alternate exterior angles. And now I can say that W is, B is equal to W, which is equal to G, so therefore B is equal to G, and that is the transitive property. And now that I've shown that B and G are congruent, I can now say that N is parallel to M because of the alternate exterior angles converse. Okay, so that's two different ways that we could do number 7. Those are not even the only ways. There are a lot of other ways that this could be done, but that's two different correct ways this one could be done. Okay, so now N is parallel to M, R is 80, and B is 100. prove that C is equal to X. So step 1, N is parallel to M, R is 80, B is 100. And all of that is given. Okay, step 2. Now the first thing that I notice is that B and R are consecutive interior angles of P and Q, and they do add up to 180, so I can say B plus R is equal to 180. That's algebra. But since B plus R is 180, step 3, I can say P is parallel to Q because of the consecutive interior angles converse. So I can go ahead and put some parallel marks on here. And now that I've shown that these are parallel, I'm allowed to use all of my parallel vocabulary. So now I want to show that C is equal to X. I can start here at C, and I can say, C, oh, let me switch back to my pink color. C is equal to G, going from here to here, because of corresponding angles. And then I can say, step 5, G is equal to X, going from here to here, because again, corresponding angles. And now I can finally say 6, C is equal to G is equal to X, so therefore C is equal to X, and that is the transitive property. Okay, 3 more. G is equal to B and H is equal to B. So G equals V, H equals V, that is given. Let's mark that. G is equal, oops, I wrote that incorrectly. G is equal to B. And H is equal to V. Okay, so since G is equal to B, I can now say that N is parallel to M because of alternate exterior angles converse. But the fact that H and V are equal to each other, sorry, before I go any further, let me put my marks on here. The fact that H and V are equal to each other lets me know that P and Q are parallel, because I see that those are congruent and those are alternate interior angles. That's the converse. Okay, so now that I have all 4 of these lines have some parallel partner, I'm allowed to use all of my parallel lines rules. So I'm trying to prove now that D is equal to Y. So I'm going to switch colors here so I don't get confused with stuff. I've got D right here. I can say D can make the jump over here to H. So step 4, D is equal to H because of corresponding angles. And then step 5, I can say use corresponding angles to get to Y. H is equal to Y, again corresponding angles. And then for step 6, I can say, therefore, D is equal to H is equal to Y. So D is equal to Y because of the transitive property. Number 10. Now, this one was meant to be a level C quiz, so this one's going back and getting a little bit easier. In fact, looking at that, H is 10 and C is 170. That's very similar to one that we've done earlier. So I'm just going to say H is 10 and C is 170. Step 1, H is 10, C is 170. That is given. Now, if you look at this again, this is not one of the ones that matches up nicely. This is not one of our angle pairs that we can use for our theorems. So I'm going to need to move something around in order to get two angles that I want. I would take 170 and move it over here and say this is 170. I know those are equal because they are vertical angles. So I would say B is 170 because of vertical angles. And now I can say for step 3, B plus H is equal to 180. Because we added them together, I can say that's algebra. And now step 4, I can say, since B and H add up to 180, N must be parallel to M because of the consecutive exterior angles converse. Okay, last one. All right, number 11. Before I do this, there was a little typo on here, so I'm just going to fix this. This should have been C is equal to X. So I'm going to, first thing, write down P is parallel to Q. Let me put my marks in here. And C is equal to X. And that is given. Now step 2, I want to turn this into one of my angle pairs that I can use to prove that lines are parallel. And the easiest way I see to do this is I can jump from C over to T. So I can say C is equal to T because of corresponding angles. Step 3, now I can say X is equal to C, which is equal to T. So therefore X must equal T because of the transitive property. And now that I have the fact that X and T are congruent, that means that N must be parallel to M because of the corresponding angles converse.